In this video, we're going to get really practical and focus in on some important binomial theorem questions and really work on solving those. I'm going to start with sort of an overview of important formulas and skills, things that you should memorize, and then I'm going to go into a bunch of examples. First, I'm going to do the example where I expand this binomial using the binomial theorem. Then I'm going to get one that's a little bit more complex. I'm going to expand x squared plus 1 over x to the exponent of 4 using the binomial theorem. Then I'm going to do one where I'm going to look for the 8th term of 2x minus 3y to the 12th, just focusing in on the 8th term. Then I'm going to do a more difficult question where it tells us that the 4th term of a particular expansion where we don't know the coefficients of a and y, they tell us that the 4th term of this is 4,455 x to the 8 y to the 3. And they ask us for the values of a and b, where all we're told is that a and b are integers. So that's a more complicated question. Then after that, I'm going to carry on and I'm going to do another question where we're told that x squared plus 1 over x to the 12th will be expanded, and we want to know in which term number will we get an exponent of x to the 6th. Okay, then I'll do a question where we have x to the 4th times x cubed over 2 plus k over x to the 4th to the exponent of 8 is going to give us a constant term of, what is it here? It looks like it's, the constant term will be 2 over 42,875. Okay, we're going to be asked to figure out the value of k such that the constant term of this whole thing is that fractional constant. Okay, then after that, I'm going to continue to do some more questions. I'm going to do number 6 from exercise 1O in the textbook. In that one, we're told that the 4th term in the expansion of 2x minus k to the 8 is negative 387,072 x to the 5th, and we're asked to find the value of k. I'll do that one. Then I'll do number 7 in the textbook, where we are told that a minus b squared to the exponent of 6 gets expanded, and we want to know the coefficient of the term with a cubed b to the 6th. Then I will do number 9 from the same exercise set. We're first asked to expand x minus 5 to the 5th, and we are then asked to find the term that has an exponent of x to the 4, that has x to the exponent 4 in it, in 2x minus 1 times x minus 5 to the 5th. Okay, that's an interesting one. Then I will do number 11 from the same homework set. That one says that we have a plus b to the n, and we want to know what a and b are such that we get this specific binomial expansion. And last but not least, I am going to do number 12 in the same homework set, which asks us to prove that n choose 0 plus n choose 1 plus carrying on all the way up to n choose n equals 2 to the n. Okay, so you may want to watch all of this. You may want to watch only parts. This is actually like a table of contents of what I'm going to do. I'm going to start with an overview of important skills and things you should memorize, and then I'm going to go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 examples. So here's an overview of skills and formulas, things that you should memorize and be able to do. These are the pieces, the building blocks to be able to do the questions from this particular topic, binomial theorem expansion. First, you need to know that n choose r is equal to n factorial over r factorial onto n minus r factorial. That you should memorize. You're thinking, this is how many ways I can choose r objects out of n possible objects. For example, imagine that you're trying to get r toppings out of n topping choices for a pizza. And you're going to mix them all together, so the order of these toppings doesn't matter, but you're going to select, for example, r could be 3 toppings out of 5 possible toppings. That could be your n, and you're saying how many different pizzas could you make. The next thing that you need to be able to do is generate Pascal's triangle, and that you should be able to generate pretty quickly. You just have the 1, 1, 1, 1, add, we get 2, 1, add 3, 3 and 1, 1, add 6, 4 and 1, 1, 5, 10, 10, 5, and 1, and so on. You should be able to generate that pretty quickly. We're just taking any given 2 elements and going diagonally, adding them to get the next one. Any 2 here, we're going diagonally, adding them to get this one. Okay, Pascal's triangle. That's an essential skill. You should also memorize that Pascal's triangle is n choose r. And the top one is 0 choose 0. The next one here is 1 choose 0, 2 choose 0, 3 choose 0, all the way down. This one here is 1 choose 1, 2 choose 2, 3 choose 3, all the way down. And across each row, we're just changing this r value. So here we have 2 choose 1, here we have 3 choose 1, 3 choose 2, and so on. Okay, so that you should be able to recognize that counting this as the 0th row and counting this as the 0th column, we get n choose r in this triangle. Okay, so in the 4th row, 3rd column, we get 4 choose 3, where we're counting starting at 0. Okay, that's the next important thing to understand. Now, for the sake of consistency, what I'm going to do is I'm going to use R, the letter R, for the column, and I'm going to use N, of course, for the row, and I'm going to use K for the term number. And I suggest you do the same. And I'm going to keep consistent with these choices. Okay, so with this being said, we have a relationship between R and K. The term number in a binomial expansion is always 1 bigger than the column number, because the first term will always start with this 0th column. So this relationship always holds. Okay, and I'm using the same letters that are on the IB formula sheet so that everything should remain consistent for you. So now with that being said, the next thing that you must memorize, and it's on your formula sheet, but you should have this well in your mind, that a plus b to the exponent of n is equal to the sum from r equals 0 to n of n choose r, a to the n minus r, b to the r. This you should be able to just write out, even if it is given to you on your formula sheet. Equivalently, we could replace the a with an x and the b with a y. And I recommend that you're able to write this out regardless of whether you're using a and b or x and y. In math, we'll often interchange whether you're using a and b or x and y, and often we make the choice based on what other variables are already there. So if we have a lot of a's and b's, then we want to use x's and y's. And if we have a lot of x's and y's, we want to use we'd prefer to use a and b so that we don't get confused between what the parameter is, or sorry, what the variables are, and what's going on in the binomial theorem. And I'll discuss this more as I go through the examples. Now, this is so critical that what I want to do right here is pause for a second and just write out what this means. If you think you have this down, you might want to skip forward a little bit in the video, but I'm going to write it out. So if I have, let's take the first version. If I have a plus b to the n, I've memorized that that is r from 0 to n of n choose r. Notice that this means that r is starting at 0 and going to n, just like we have in Pascal's triangle. R is starting at 0 and going up to being equal to n. Okay, no matter which row I take, I start with r 0 and it goes up by 1 until it equals n. So that's exactly what I have here. And then I have a to the n minus r, b to the r. Okay. Now, this is the same as n choose 0, which is going to be 1, no matter what n is. It's the first element of a row of Pascal's triangle. A to the n minus 0, which is just n. B to the 0, which is 1, so I don't need to write it. Plus n choose 1, a to the n minus 1, r to the 1. Plus n choose 2, a to the n minus 2, r to the 2. Plus n choose 3, a to the n minus 3, r to the 3. And it's going to carry on with that pattern all the way to the end. Now I'll give a few more terms towards the end. So on the other side, we would end up with something like n choose, what are we? Let's back off. Not n, that'd be the last term. Not n minus 1, that's the second to last. Let's go n minus 2, that's the third to last term. A to the n minus, a to the 2, r to the n minus 2. Okay, notice how this r is always matching this r here. And I apologize, I was writing r here all the way through. This should be b. Okay, so the exponent on b is matching that subscript there on the choose because it's r all the way through. The exponent here is 1, 1. Okay, and so then after this term, I'm getting closer to the end. I'd have n choose n minus 1. I'm almost at the end of Pascal's triangle. A to the 1. b to the n minus 1. R, R. Okay? And then the very last term would be n choose n, which equals 1. A to the 0, which means it's not there. B to the n. Okay, so that's the expansion. Now, because it's so important, I'm going to go through just expanding a plus b squared, and then I'll do a plus b to the 7th using the formula, just to make sure it's crystal clear. If you want to skip ahead, that's fine. So here I'm going to use the formula. It says that I start from r equals 0, I go up to n, which in this case is 2, so I'll put a 2. I have n choose r, but in this case n is 2. I have a to the n minus r, but in this case n is 2. B to the r. Okay, so this is equal to 2 choose 0 a squared, because I'm subtracting 2 minus 0, b to the 0, plus 2 choose 1 a to the 1, because now that r is 1, I have 2 minus 1 is 1, b to the 1, plus 2 choose 2 a to the 0 b squared. Because now that I'm on this last term, when r equals 2, I plug in a 2. 2 minus 2 is 0, and my r is 2 there on the b term. Now these coefficients I can either calculate, well, I can calculate using my graphing calculator if I want. Quick reminder on how to do that. You would just go math, and then come over to probability, choose option 3 and choose r, and then put in whatever they are. So in this case, I have 2 choose 0. The answer is going to be 1, but let's just do it there. There it is, 1. Or you can get your n choose r by using the fact that n choose r equals n factorial over r factorial n minus r factorial. Plug in the numbers. Or in simple cases like this, I'm just using Pascal's triangle. I'm on the second row because n equals 2. So I come to a Pascal's triangle, and here I am on the 0, 1, 2 second row. That's where those values live. So I can just very easily, on the side or a scrap piece of paper, do that. So I know that this is 1 a squared b to the 0 plus 2 a to the 1 b to the 1 plus 1 a to the 0 b squared. Like that. Or in other words, a squared plus 2ab plus b squared. Okay. Now we could have got that much faster by just multiplying a plus b times a plus b, and of course we would get this same result. But the point here was to illustrate how this formula works. Okay. I'm going to do it one more time in full with a plus b to the 7, and then I'm going to carry on with helpful skills, facts, formulas for you to memorize before then doing a bunch of examples. Here I have the sum from r equals 0 to 7, because that's what n is, of 7 choose r, a to the n, well that's 7, 7 minus r, b to the r. And I'll go through and write this out. This means I have 7 choose 0, a to the 7 minus 0, b to the 0, plus 7 choose 1, a to the 7 minus 1, 6, b to the 1, plus 7 choose 2, a to the 7 minus 2, 5, b to the 2. Because that's what the summation notation means, right? We're incrementing r by 1 each time. Plus 7 choose 3, a to the 7 minus 3, that's 4, b to the 3, plus 7 choose 4, a to the 7 minus 4, that's 3, b to the 4, plus 7, choose 5, a to the 7 minus 5, that's 2, b to the 5, plus, we're almost there, we're on to r equals 6 now, so 7, choose 6, a to the 7 minus 6, that's 1, b to the 6, plus, finally, r equals n, 7, choose 7, a to the 7 minus 7, that's 0, b to the 7. Okay, notice the pattern. Notice how the exponent on a starts at n, and it goes down by 1 every single term. And the exponent on b starts at 0, and it goes up by 1 every single term. And r increments in our choose. The 7 stays there. That's the n. And this is what it is. Okay. Now, to get the coefficients here, instead of using factorials and instead of using my calculator, I would just use a Pascal's triangle. It's so much faster, right? Here I go. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6. I did that mistake twice today. 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Do I have enough? 0, 1, 2, 3, 4, 5. Not quite. One more row to get to n equals 7. 1, 7, 21, 35, 35, 21, 7, 1. Okay, so then these are my coefficients. Notice that I have n equals 7, and so I have 8 terms because we start counting with r equals 0. Okay, so the number of terms is always n plus 1. And here I have 1, 2, 3, 4, 5, 6, 7, 8. That's n plus 1. Okay, so I would have 1, a to the 7, b to the 0, plus 7, a to the 6, b to the 1, plus 21, a to the 5, b squared, plus 35, a to the 4th, b cubed, plus 35, a to the 5th, hold on here, a to the 3rd, b to the 4th, plus 21, a squared, b to the 5th, plus 7, a to the 1, b to the 6, plus 1, a to the 0, b to the 7. Anything to the 0 is 1, so those ones didn't need to be written. Coefficients of 1 don't need to be written. And there we have the expansion. Okay. Other helpful tips, as I just said, the number of terms in your expansion will be n plus 1. That can be very, very helpful. Okay. The first term will occur when r equals 0, right? We saw that in every single example. When r is 0, that's our first term because we start with r equals to 0. Our last term comes when r equals n. Okay, and we saw that here as well. R equals n, 7, choose 7. Last term. R equals n, 2, choose 2. Last term, right? Because r keeps getting incremented until it equals n. So that's our last term. Now, if we're in the situation where we have a middle term, that middle term is going to be n divided by 2 plus 1, where n has to be even. Why does n have to be even? Well, when n is even, the number of terms is odd, and you have to have an odd number of terms for there to be a middle term, right? If we have 3 terms, there's a middle term. If you have 5 terms, there's a middle term. The number of terms must be odd, so n must be even. And then you take that even n, divide it by 2, and add 1. You'll get the middle term. Okay? Not essential, but handy to know, especially if you're the type of student who really likes formulas. As mentioned before, the term number we're on, current term number, which we will use the letter K for, is always equal to R plus 1. Okay, this can be very handy, especially if you're the type of student who likes formulas. K equals R plus 1. The current term number is R plus 1 because we always start with R equal to 0. And so the very first term is, well, 0 plus 1. And then we move on. R is 1 in the second term. So again, we have R plus 1. Just frozen here for a second. Okay, and the last sort of mini formula that's quite helpful to know here is that your exponent on A plus your exponent on B, so exponent on A plus your exponent on B for any term at all equals n, right? Because your exponent on A is n minus r, and your exponent on B is r. So if you add those together, you get n. And that can be quite handy because if you have a single term, you can figure out n pretty easily. Okay? Then the last essential piece is the formula for the kth term. Okay? So if you have the kth term in the sum, then we're saying that r, of course, is k minus 1. R is 1 smaller. And the kth term will be n choose r, always, a to the n minus r, b to the r, right? Where r is k minus 1. All right, so that's pretty much the core information which you have to have memorized and down pat. Once you have that, then you can build on it for examples. And as I say, I'm going to run through a bunch of examples next. In the first couple examples, I'm just going to expand using the binomial formula. So here we have 2x minus 3y cubed. I'm going to say, okay, here's my binomial formula. I just literally write it out every time I do a question to make sure, A, I'm practicing it, and B, I have it handy here for reference. Okay, and then I'm going to write out what I know. I know that n is 3. I don't care about k and r because I'm going to get all the terms. So there's no particular term I'm focused in on. A is 2x. B is negative 3y. Okay, so I'll just expand it. Oh, and also I guess I need a quick little Pascal's triangle here so that I can get these terms very easily. N is 3, so I want the third row, or the fourth actual row if you wish, because we start counting rows at 0. Okay, so here's the third row right here. This is the one I'll be using. And of course, I can double check. I have four numbers here, which is what I would expect because the number of terms is n plus 1, and my n is 3. Okay, so just little checks I'm doing along the way. So I have a 1 from this one here times a to the n, which would be 2x to the 3, and then b to the 0, which I don't need to write, plus the next coefficient is 3, a to the n minus 1, which is 2, b to the 1, which is negative 3y, okay, plus the next coefficient, 3a, which is 2x, to the n minus 2, which is 1. I'm just walking these down, 3, 2, 1, and negative 3 squared. And then my last term, and I'm just going to pull this down here so I have a little more space. My last term is a coefficient of 1. My a term, I don't really need it anymore because it's to the exponent of 0, and anything to the 0 is 1, so I don't need that. And I'll put in my last term here, negative 3y cubed. Okay, and then it's just a matter of simplification. So this is 8x cubed plus 2 squared is 4, that's 12x squared times negative 3y. I guess I need another line. This is going to be a 6x times a 9y squared. And this is going to be a negative 3y cubed. Cleaning it up, I get 8x cubed minus 36x squared y plus 54xy squared minus 3y cubed. Okay, so that would be the expansion of that binomial using the binomial formula. Let's do another one. Let's get x squared plus 1 over x to the 4th and expand that using the formula. Again, I would just write it out. Whoops. I'd go a plus b to the n is the sum, r equals 0 up to n choose r, a to the n minus r, b to the r, and I'd summarize what I have. N I have is 4. R and k I don't care because I'm going to go through all the terms. A is x squared, b is 1 over x. Okay, so here I go. And I'll get a Pascal's triangle. Now n equals 4, so I'm looking at the the 4th row, or the 5th. It's really the 4th row because I start counting at 0. So 0, 1. Let's just get this Pascal's triangle out really quickly. And after you do a few of these, you'll actually start memorizing the first few rows of Pascal's triangle. But for now, I'll just continue to write them out. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Perfect. So this is the row I want right here. I didn't even need this last row down here. Those are my coefficients. All right, so my first term is going to be n choose 0, or 4 choose 0, which is this one right here, 1. A, which is x squared, to the n minus 0, that's n. B to the 0, so I don't need to write it. Plus, next coefficient, 4. A, drop down the exponent by 1. B to the 1. Next, I have the next coefficient is 6. A to the 2. I just keep decreasing it. B to the 2. I increase it. It was 0, 1, 2. Next, I get 4. That's this 4 here. X squared to the 1. 1 over x to the 3. And last but not least, I get 1. X squared to the 0. Well, I don't really even need to write it because anything to the 0 is 1. 1 over x to the 4. And now it's just a matter of simplification. X squared to the 4, that's x to the 8 times 1 is just itself. Here I have 4. This is x to the 6 times x to the negative 1. So that's going to simplify on my next line down to the x to the 5th, like that. Here I'm going to have 6 x to the 4 times x to the negative 2. So I'm going to get a 6 x to the 2. Here I have 4 x squared x to the negative 3. So this is going to be plus 4 x to the negative 1. And lastly, this is x to the negative 4. So I have last term of x to the negative 4. Okay. So that would be the expansion of this binomial here using the binomial expansion formula. Next example, I'm going to find the 8th term in 2x minus 3y to the 12th, again using the binomial theorem. So I'll write out that binomial theorem. I have that a plus b to the n is the sum from r equals 0 to n of n choose r, a to the n minus r, b to the r. This time I'm going for a specific term. So my k is 8. That's going to tell me what my r is as well. So let's write these things down. I have that n is 12, first off. I have that a is 2x and b is negative 3y. I have that k, the term number, is 8. And so r is going to be 7, is 1 less than the term number. Okay. So to get the 8th term in this expansion, basically now it's just a matter of plugging things in. Not to this formula, but to this part of the formula with the constants that I have. So basically, I'm now looking at 12 choose 7, 2x to the 12 minus 7, negative 3y to the 7. That's it. Now 12 choose 7 at this point, since I'm just doing one single choose, and since I have a fairly large n, I would either use my graphing calculator or I would use n factorial or f factorial over r factorial times n minus r factorial. So let's pull up the graphing calculator for the sake of argument. If I were to use the graphing calculator, I would go math, then I'd come over to probability. I'd pick option 3 and choose R. I put in my value of 12, and then here's the history of what I've been typing. And then I would come over and I would pick 7. Enter, 792. So 792, 2x to the 5, negative 3y to the 7. 792 times 2 to the 5 is 32, times x to the 5, times negative 3 to the 7. Well, I'll jump back over to the graphing calculator. Negative 3 to the exponent of 7, well, I know that that's going to be a negative, so I'll just go 3 to the exponent of 7 and see what that is. 2,187. So negative 2,187 y to the 7. So I guess I have that 2,187 times 32 times 792 from the 12 choose 7, and that gives me, oh my goodness, an enormous number, 55 million and change. So I'll have negative 55 million, 427,328 x to the 5, y to the 7. The next question is similar in the sense that we're just going to look at one term in the expansion. The difference is this time we're asked to find the coefficients on x and y. This is a little bit tricky because a, x, b, and y are all in our formula. So we have to be careful with what represents what. So the question is, the fourth term in the expansion of ax plus by to the n is 4,455, x to the 8, y to the 3. Find a and b where a and b are integers. Okay, well, what do I know? N Don't know. A and B, or whatever I want to call this first piece and this second piece, I don't know, although I do know that I have x to the 1, y to the 1 inside there. Okay, so my first piece is ax. Maybe so I don't get confused, I'm just going to write ax, and my next piece of that binomial is by. What about k, the term number? Well, I know that it is 4. Therefore, I know that r is 3. R is always 1 less than the term number. And I know that I have n choose r. Instead of getting myself confused with a, I'm just going to put a box to the n minus r and put a box to the r. Okay, just for my own, keeping things straight. I prefer to use boxes instead of putting an a and suddenly thinking that it's this a here, for example. Okay, or I might, what I might do is use a capital A and a capital B and put a capital A and a capital B. I could make dummy variables like that, or a U and a V. There's lots of choices. I'm personally just going to use a couple of boxes and be careful. So I know that I am on the 4th term, so R is 3, and I don't know. So what I have here is n choose 3, ax to the n minus 3, by to the 3, right? That's all I know so far. But I know that whatever this is, it equals 4,455 x to the 8, y to the 3. And that's going to turn out to be enough to solve this problem. I'm writing it again over here so that I can say equals 4,455 x to the 8, y to the 3. Now, right away, I can see that my n can be determined. In fact, I could have got it a little bit higher up just from looking at this here, but I can certainly, well, I can see it here as well. Because n, remember, is this exponent plus this exponent. Because we have n minus r plus r is n, right? So I know that my n is in fact going to be 11. And so I can change this to 11 choose 3, and 11 minus 3 is 8 here. Okay, and that makes sense because now I'm going to get an x to the 8, which matches this x to the 8, and a y to the 3, which I already had. So that all checks out. Now I'll quickly go over to a graphing calculator because this is going to be a relatively large number, and I'll get, I will get math, come over to probability, and choose R, 11, choose 3. I get 165. Okay, fine. So I have 165 a to the 8, x to the 8, b cubed, y cubed equals 4,455 x to the 8, y cubed. Okay, so far so good. I could divide both sides by 165 to make things a little bit simpler if I wanted. So if I go ahead and do that, I actually get, let's see here, I'll write it out this way just so that it's crystal clear for you. This is my numerical coefficient because a and b are going to have values. This x to the 8, y to the 3 is just going to be part of that term. I don't really care about the x to the 8, y to the 3 anymore because my objective is to find these values. So I have 165 a to the 8 b cubed equals 4,455. If I divide by 165, I get 27. So I have a to the 8b cubed equals 27. And now, because we were told that a and b are integers, we can solve this, right? If we look at this piece here, we can see immediately that without worrying about a, we could say that b is 3. If b is 3, we get 3 cubed is 27. That's fine. And if b is 3, then a has to be 1, or negative 1, I suppose. That's the only way to make sure that we get 27. If b was a 2, that would kind of mess things up because we'd have an 8, and a couldn't be an integer to make that work. If b was a 1, then we're saying a to the 8 equals 27. Well, there's no integer a that makes that work. So in fact, because of these exponents and because we're told that they're integers, we're able to get this solution. If we were not told that we have integers and the numbers didn't work out so nicely, we wouldn't have been able to do the problem. But because of that, we were told we have integers, and because the numbers work out nicely, for those reasons, we are able to do the problem. So that's rather important. So then all in all, we could say our solutions are that a equals 1, b equals 3, or we could have an a of negative 1 and a b of 3. Whoops, b equals 3. Because of that even exponent, right? Either of these work. So that would be the solution. In this question, we're given x squared plus 1 over x to the exponent of 12. And we're asked what's the term number that contains x to the exponent of 6? So we need to find k, and so we're going to focus in on using the formula for the kth term, even though we don't know what k is. We know that the kth term will be given by n choose r a, which in this case is x squared, but I'll put an a for now. A to the n minus r, b to the r, right? That's the generic term for any term in a binomial expansion. And we know that the kth term, k equals r plus 1, right? Or k minus 1 equals r, because r is always 1 less than the term number. The term number is always 1 more than r. So here now, I want to end up with an x to the 6 plus some sort of coefficient. So let's see what we have. We know that n is 12. We don't know what k and r are. We know that a is x squared and b is 1 over x. So we have 12 choose r, whatever r is, x squared to the 12 minus r, 1 over x to the r, and this is going to equal something x to the 6th, because that's what we're asked to do. Make sure that it's x to the 6th. Now we can simplify this a little bit. 12 choose r is going to be some constant. I don't know what it is, and to be honest, it doesn't really matter. So I'm going to have some constant here. I'll just still call it 12 choose r. X squared to this exponent, well, I can multiply. This is x to the 2 times 12 minus r, exponent rules. And this is the same as x to the negative 1 to the r. This will be something x to the 6. I have 12 choose r. This is x to the 24 minus 2r times x to the negative r equals something x to the 6th. And I'm just simplifying this left-hand side as much as I can. I have 12 choose r x to the, I'm multiplying so I can add the exponents, minus 2r plus negative r. So this is going to be 24 minus 3r equals something, x to the 6th. And I'm not asked anything about the coefficient. I don't care. And this is just a number. I don't care. What I want to know is, when will this equal 6? So I'm really solving 24 minus 3r equals 6, which I can solve pretty easily. I get, what is that? 18 equals 3r, r equals 6. Okay? So r has to be 6 for this term to be x to the 6th. And if r is 6, then we know that k has to be 7, because the term number is always 1 bigger than r. So that's my answer. K equals 7. It's the 7th term. Right? Maybe I should write 7th term so that I'm actually saying which term it is instead of just giving a value of k. In the next question, it's similar but different. So here we have x to the 4 times the binomial x to the 3 over 2 plus k over x to the 4, all to the exponent of 8. And we're told that the constant term is some nasty fraction. And we're asked to find the value of k, this k right here. Now, first of all, the constant term will not be necessarily at the very end, because we have an x to the negative 4 in here, or a denominator of x to the 4, and we have an x to the 4 out front, where it's not so clear where exactly the constant term will show up. But that's not really a concern. My biggest concern, actually, at this point, is that they threw me a k, and k already stands for something. And binomial expansions are pretty complex in that there are lots of different variables to keep track of. So the very first thing I would do is I want to get rid of this k and replace it with some other new letter. I'm going to replace it with u. And if I'm writing an exam, I would scroll down as far as I can to wherever my answer box is, and in very light pencil or maybe very tiny writing that only I could understand and I could easily scribble out later, I would put for myself a note, something like u has to go back to k. Just because as I'm doing the problem, I could very easily forget that u is a variable I introduced. And technically, if you are doing things properly, and we should, I would say here, let u equal k, so that I can work with u all the way through and not worry about it. And then at the end, I have this little reminder to myself to give my answer back as k equals whatever. Okay, so that's just sort of exam writing tip. Now, what I need to do here is I need to figure out when this whole thing has x to the 0, because that's when I have my constant term. And when this whole thing has x to the 0, that's going to be when this part of it has an x to the negative 4. Because x to the negative 4 times x to the 4, x to the 0, 1, that's the constant term. So in my binomial expansion, I want to see when am I going to end up with x to the negative 4. And then from there, I could figure out what the value of u has to be. So I'm going to go ahead and say, okay, well, the kth term, whichever term that happens to be, is going to be n choose r, a to the n minus r, b to the r, and then my a is x cubed over 2, and my r is u over x to the 4. And this thing has to equal some constant times x to the negative 4, right? That's what I'm looking for, because then at the end, when that's multiplied by x to the 4, it is a constant term. I don't particularly care at this stage what the constant term actually is. Of course, at the very end I do, but for now, I would just like to figure out what this value of r is. That would make me happy. I know n is 8, so I can replace my n with 8 here and here. So that's 8 minus r and 8, choose r. But my objective at this point is just to figure out what r is. This is a number. It has no bearing on what r is. What has a bearing on what r is just like in the previous question, when I'm going to end up with an exponent on this side that matches the negative 4. So I'll simplify the left-hand side until I can figure that out. So I have some constant. I'll just write it as the constant. I have 1/2 to the 8 minus r, x cubed to the 8 minus r, u to the r, and 1 over x to the 4 to the r equals some constant x to the negative 4. I'm going to get my constants all out towards the front. 8, choose r, 1/2 to the 8 minus r, u to the r. That's what's going to give me my coefficient. X cubed to the 8 minus r. That's x to the 24 minus 3r. This is x to the negative 4 to the r. Okay. I have this rather unpleasant looking coefficient here. Okay. This is going to be an x to the negative 4 to the r. That's minus 4r. Add them together, I get x to the 24 minus 7r. And I want this part to match this part. In other words, I would like 24 minus 7r to equal negative 4, which I can solve for r fairly simply. That gives me 28 equals 7r, divide both sides by 7, r equals 4. Okay, so r equals 4 here. Now that I have r equals 4, I know my term number, 5, because the term number is always one more than the value of r. Additionally, now that I know that r is 4, I can come back up here anywhere I want. I might actually come to this line here, substitute in the r, and figure out what my coefficient is. Okay, so that will be the next piece. Because, of course, they tell me that the coefficient is going to have to be, where did it go? Up, up, up. That's the last question. Here it is. That the coefficient has to be this rather unpleasant fraction. Now, you might be saying at this point, well, why is that if this is x to the negative 4? Well, because, don't forget, at the very end, we multiply it by x to the 4. So this really is the constant term. So, r is 4. I'm going to substitute r in here, here, and here. And here if you want. 24 minus 7 times 4, that's negative 4. That matches right there. Okay, so that's fine. So my constant, I have 8 choose 4 times 1/2 to the 8 minus 4 u to the 4, and that has to equal 2 over 42,875. So now it's really just a matter of solving for u. Notice that I didn't evaluate this, I just plunked it in so that I'm showing exactly what's going to happen step by step. Now 8 choose 4, I might as well just come over to the GDC for this. We get 70. 1/2 to the 4, that's going to be 16. So let's see here, that's 70 over 16 u to the 4 equals this fraction. Multiply both sides by 16 over 70. (16 over 70), I suppose I could reduce that to 8 over 35, which, well, that's 16 over whatever this denominator is. We're looking at 35 times 42,875 equals, what is that? 1,500,625. 1,500,625. And now I'll take the fourth root of both sides. So u is the fourth root of that. The fourth root of 16 is 2. And let's see what the fourth root of this number is. I can actually just go second answer to the exponent fourth root. Fourth root is 1 over 4, or 0.25. I find that faster than going and finding the fourth root. So I get 35. And there we have it. U equals 2 over 35. And at this point, when I come to put in my answer, I would notice that on the box I said U goes to K, and it would remind me, oh yes, right. So therefore, K equals 2 over 35. That solves what we've been asked to solve. I'm going to do 5 questions from the textbook now. From exercise 1O, that's not a 10, it's 1O. Sure looks like a 10. It's pretty hard to write it any other way. 1O. I'm going to do number 6, 7, 9, 11, and 12. Number 6 says the fourth term in 2x minus k to the 8 is negative 387,072 x to the 5th. Find the value of k. All right. The very first thing I'm going to do is I'm going to get rid of the k. I'll say let u equal k. I don't want to use k because I have enough different parameters to deal with. So I have it like that. And again, if this was on an exam, I'd very lightly say u goes to k right there to remind myself at the very end that what I solved for as a u should be called k. Okay, we're given a specific term. So the kth term is, of course, n choose r, a to the n minus r, b to the r, where k, that is term 4, is 1 more than r. So my r is 3. I also know my n. My n is 8. and I know my a is 2x, and I know my b is negative u. So all in all then, in this term, I have the value 8, choose 3. I have 2x to the 8 minus 3, negative u to the 3. Okay, and I'm told that that is equal to negative 387,072 x to the 5. All right, very well. 8 choose 3. Now, when I see that, I'm torn between using a GDC if I'm allowed one and just calculating it straight off. I probably would use the GDC in an exam situation just to make sure I don't make a miscalculation, but I'll do this one longhand here. So we have 8 factorial over 3 factorial times 8 minus 3, which is 5 factorial. I'm looking at the 5 and I'm canceling it out, and I'm going 8 times 7 times 6. And then 3 times 2, 3 factorial is 3 times 2, which is 6. So basically I have 8 times 7, that's 56. So 8 choose 3 is 56. Then I have 2 to the 5, x to the 5, negative u cubed. And that's a negative. Equals negative 387,072 x to the 5. I'm encouraged by the fact that they both have x to the 5, so that's good. And since I'm solving for u, I can divide both sides by x to the 5. I'm not solving for x. If I was solving for x, it would be a whole different story, but I'm solving for u. 2 to the 5, that's 32, so I have 56 times 32. You know, this could come up where you have no GDC. The numbers are actually workable. 8 carry a 1, 16, 2, 9, 7, 2. At least so far they are. Maybe dividing here would be too much for a non-GDC section. 2, 7, 9, 2. Negative, from this negative u cubed equals negative 387,072. Okay, at this point, yeah, I'll pull up a calculator, make this a little bit easier. 387,072 divided by 2792 equals, well, is that right? That's not so pleasant. Okay, so let me just go back through my calculations here. 2, 1, oh, here it is. Okay, so it's not 2,792, it's 1,792. Okay, and so, yeah, so if I had a GDC, I shouldn't have done this by hand. All right, so we're solving for u, so I'm going to pull up a calculator here. I'm going to go 387,072 divided by 1,792. I get 216. That looks much better. U cubed equals 216. And now I'll cubed root both sides. So on my GDC, I'm just going to go 216 to the exponent bracket 1 divide 3 bracket. That's the same as a cubed root, and I get 6. U equals 6. And of course, because I made that substitution, I should actually say k equals 6. And that should be it. Okay, that's number 6. Number 7 says, for a minus b squared to the exponent of 6, what is the coefficient of the term in a cubed b to the 6? Okay, now we're looking at a specific term, so I only need to say, okay, well, the kth term is given by n choose r a to the n minus r b to the r, where k, of course, is 1 bigger than r. But here, they're giving me a's and b's, so I don't really feel like using a and b down here anymore. I might prefer to use x and y this time. Okay, x plus y to the n equals ... Or, in fact, since it's pretty direct, I might even just put brackets in the place of the x and the y and put in the values from the binomial directly. I have an a here and a negative b there. Now, what do I know? N, I know, it's 6. K, I don't know. R, I don't know. So I have 6 choose R, a to the 6 minus r, negative b to the r is going to equal something, a cubed b to the 6. Okay? And so I need to figure out, okay, so for what value of r am I going to get a cubed b to the 6? And I can work from there. This is not really too difficult because the only a shows up here and the only b shows up here. I could actually use either of these to figure that out. Oh, I see. So, in fact, this is actually a great case to show it's always good to double check and do more than possible. When I'm looking at the green ones, I'm thinking, oh, r must be 3 because that's the only way for me to get a to an exponent of 6. So I'm thinking, okay, r equals 3. And then I'm doing it again, even though I already have r, I'm doing it again with this term, and I'm thinking, you heard me say, what's going on here? If that's a 3, I don't get 6. And then I'm like, okay, so where's the error? And I'm checking back up. Well, here's the error here. It said b squared. So the error was that, in fact, I missed a squared there. And now the 3 actually makes sense. Okay? It's always good to do things more than once if possible. If you can solve it in 2 different ways, go ahead and do that because you'll catch mistakes. All right. So here now, this makes sense. R equals 3 because when I put 3 here, I get a to the 3. That's correct. When I put 3 here, I get, never mind the negative part, but I get b to the 6th. That's correct. So r is in fact 3. And now I can write this as 6 choose 3, which is an actual value, a to the 6 minus 3, which is 3, negative b squared to the 3. And let's see what that is. That is going to be 6 choose 3. That one I could do with factorials. Or, you know, if I was on an exam and I had my GDC, I would certainly use it to make sure I'm not making a mistake. I see this as 6 times 5 times 4. And then the 3 factorial and the 3 factorial go. This is 3 factorial, which is 6. So that goes with the 6. I'm left with 20. 20 a cubed. This is negative. Well, it's going to be negative, but if you really want to see it in a little bit of a pedantic way, I might write it this way just to show very clearly that this is a negative 1 cubed times a b squared cubed. So I have negative 20 a cubed b to the 6, which answers the question. They said, what is the coefficient of the term in a cubed b to the 6? Well, it's going to be negative 20. The coefficient is negative 20. Number 9 in the textbook, exercises 1.0, has 2 parts. The first part just says expand x minus 5 to the exponent of 5. Okay, 5 for my n is pretty small. I'm going to use Pascal's triangle. I'm going to just write it out here. Actually, maybe I'll make it a little bit more condensed than that. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Is that enough? Row 0, row 1, row 2, row 3, row 4, row 5. Perfect. So that's the row I need. And my A is x, my B is negative 5. Okay, so I have 1 x to the 5, negative 5 to the 0, so I don't need to write it, plus 5, x to the 4, I just bring it down 1, negative 5 to the 1, plus 10, x to the 3, negative 5 squared, plus 10, x to the 2, negative 5 to the 3, plus 5, x to the 1, negative 5 to the 4, plus 1, x to the 0, so I don't need it, negative 5 to the 5. Okay, and I can simplify this. This is x to the 5. This is minus 25, x to the 4. That'd be positive 25 times 10 plus 250, x cubed. Here we have negative 125 times 10, that's negative 1250x squared. Here we have positive 25 times 25, which eludes me for a second. I think it's 625. So I have 625 here times another 5. So that would be 3,125x plus 3,125x minus, because it's an odd exponent, 5 to the 5th. And I'll get that on a calculator. Oh, of course, I just did it. 3,125. 125. Okay, so that's the expansion. That's part A. Part B says, hence, find the term in x to the exponent of 4 in 2x minus 1 onto x minus 5 to the 5. So this, we just found the expansion for. It's right here. And now we're multiplying this polynomial with 6 terms by this binomial. So if we were to actually do that, we would actually have 12 multiplications. We'd have 2x times each of these terms, and we'd have negative 1 times each of these terms, and then we'd have to collect like terms. But it would be a waste of our time to do all of that because they're just saying we want the term in x to the exponent 4. So we have to think here. When we multiply each of these by 2x, which one will give a term x to the 4? Well, we have 2x. It would be this one here. When we multiply by 250x cubed, we'll get 500x to the 4. So that's part of this term x to the 4. When else are we going to get an x to the 4? Well, when we multiply negative 1 times negative 25x to the 4. That will also give us a term in x to the 4. All the other multiplications are going to give us terms with different exponents on x. These are the only two that matter. And so now when I add them together, I get 525x to the 4. That's the collecting like terms part. And so my answer then is this here is the term in x to the 4. That's all I need to do. Number 11 says, find the binomial power in the form a plus b to the n with this expansion here. Find the binomial power. This is a binomial. This is an exponent. This is a binomial power in the form a plus b to the n. In other words, just find a plus b to the n that equals this expansion. Okay, that's what number 11 is asking. Find the binomial power in the form a plus b to the n with the expansion, blah, 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 blah. All right. First thing I notice is I can get r, I can get n very easily. I can get n because remember n is the exponent on a times the plus the exponent on b. So I can see in this term here, for example, 2 plus 1 is 3, n equals 3. In this term here, 1 plus 2, 3. 3, 3. They should all be the same, and they are. They all give us that n is 3. Okay, so that part is solved. this right here, I already know that it's a 3. What else? Well, I know that this here is not a 1, and neither is this. So A and B are not simply X and Y. So let's expand this out so that we can see what's going on. We know A plus B to the n, well, n is 3. And I can use, well, I'll use Pascal's triangle. This is pretty simple. I actually have this one memorized. When n is 3, 0, 1, 2, 3, I have 1, 3, 3, 1. So I have, now let's see here. Yeah, this is my A. So I have 1a cubed, b to the 0, plus 3a squared, b to the 1, plus 3ab squared, plus 1b cubed. And I need that to match with 27x cubed minus 108x squared y plus 144xy squared minus 64y cubed. Now it's pretty obvious here that b is y with something, and x is a with something, because the exponents all match. The easiest way to solve for a and b is to look at the first and last terms, respectively, because they only involve a and b, respectively. So I have that a cubed equals 27x cubed. So in other words, if I take the cubed root of both sides, a equals 3x. No doubt about it. And I also have that b cubed equals negative 64y cubed. So if I take the cubed root of both sides, I have that b equals negative 4y. No doubt about that either. So in fact, this is quite simply 3x minus 4y cubed. Okay, and if I wanted to, I could do the expansion to double check that it is in fact this here. This is the kind of thing on an exam where I would actually go in the margin and I would say expand to double check. And literally my little shorthand was I used to go 2 times check, double check, just faster. And I'd put that there so that if at the end of the exam I had extra time, then I would double check this. If I didn't have any extra time, fine, I would just leave it because it's probably right. Okay, I'll leave the double checking of it to you actually as an exercise if you want to try that. Number 12 says, show that n choose 0 plus n choose 1 plus n choose 2 plus ... all the way up to n choose n equals 2 to the n. Okay. This might appear a little bit intimidating, but they're telling you what it equals. So in fact, in a way, you can just think of it as, ooh, they've asked me to evaluate this, but they're also telling me what the answer is going to be. So that can actually be helpful. Now, what do I have here? I have a sum of choose statements. If I have a sum of choose statements, I have a row of Pascal's triangle, right? Or I could think of it as a binomial theorem, but there's just no A's and B's. There's no X's and Y's. So this is the sum from, well, let's say R equals 0 up to n of n choose R, right? Throw in a 0, you get your first term. Increment to 1, you get your second term. All the way up to increment to n, you get your last term. But this looks awfully familiar, doesn't it? Isn't this just a simpler version of n choose R, a to the n minus r, b to the r? right? Isn't this just the binomial theorem in some sense? How could I choose my A and my B so that these two lines are equal? Well, if A and B had the value of 1, these two lines would be equal, right? Because 1 to the anything is 1, and 1 times n choose r is n choose r. So I can say that this equals this, and now I've got a binomial theorem where A equals 1 and B equals 1. This is A plus B to the n. It's the binomial theorem. But I've just done it where A and B are 1. So in other words, I have 1 plus 1 to the n. And clearly, that's 2 to the n, which is what I was asked to prove.